Hello everyone, this is Zeenath Jaha Begum from MLR Institute of Technology. So today I'm going to discuss one of the topic of automata and compiler design, that is types of finite automata. So previously we discussed about the introduction about the finite automata. In that we discussed about the string, we discussed about the alphabet as well as the languages. So here, now coming to the types of finite automata. Here there are two types of finite automata. One is deterministic finite automata and other one is the non-deterministic finite automata. So here we are going to discuss about the deterministic finite automata. What is the deterministic finite automata? What are the different tuples are there in the deterministic finite automata? We are going to discuss in the today's class. Coming to the deterministic finite automata. So here we just want to know what is the deterministic finite automata and how it is going to be work. What are the different tuples of deterministic finite automata will be there. Now coming to the definition of the deterministic finite automata. So deterministic finite automata is nothing but it is the input symbol where each and every state will have exactly one input transition. That means if we have three states with the two inputs, so for each and every state we should have exactly one transition. In the same way, in the other words, we can say that as it is a finite number of state, that machine is also called as deterministic machine or deterministic finite automata. Now coming to the formal definition of deterministic finite automata. So here deterministic finite automata or it a non-deterministic finite automata, we have a 5 tuples there. So 5 tuples are nothing but this one. That is nothing but we can say as this one, Q, sigma, transition function, Q0 and capital F. So we discuss each and every transition. We are discussing each and every 5 tuples which are going to be used in the deterministic finite automata. Now coming to the first one, capital Q. So capital Q is nothing but that is the finite set of states. For example, if we take one example here of a transition diagram. So here the capital Q will be nothing but that will be the finite set of states. That means in the given transition diagram we are having 3 states. So capital Q is equal to nothing but it can be Q0, Q1 as well as Q2. Now coming to the transition symbol, that is nothing but the summation symbol which we can say. So that is nothing but this is known as the input alphabet. So input alphabets already we discussed in the last class. So alphabets are nothing but, like for example, in the same figure, if I give like this. So the input alphabet, the transition, the summation, it can be A, B. This is known as the input alphabet. That means this is one alphabet and this is another alphabet. Now coming to the transition function. This is very, very important, and it will be different for DFA as well as it will be different for NFA. That means for DFA and NFA, Q summation Q0 F will be similar, but coming to the transition function, it will be different. So now in the DFA, the transition function can be written as transition, that is capital Q into summation tends to capital Q. That means capital Q stand for set of states. That is nothing but a state with input alphabet to the next state. Present state into input alphabet which tends to the next state. So this we will be elaborating with the help of the example in the next slide. So this is important that whenever we discuss about the DFA, we have to know what is the transition function. So transition function for DFA is Q into summation tends to capital Q. So first Q is nothing but that is the present state and last Q is nothing but that is the next state. Now coming to the Q naught. Q naught is nothing but it is the initial state. So initial state will be denoted with the arrow. That means the first state in the transition diagram will be considered as the Q naught. And the last one, that is nothing but that is the final state. So final state is nothing but the state which we are the input alphabet where it is ending. That means the string wherever it is ending, that will be considered as the final state. So final state, it's not compulsory. It will be every time it will be at the last. It can be at the first state, it can be the second state, or it can be the last state. So whenever we say about the final state, it doesn't mean that it should be every time it should be in the last state. And the final state can be declared as or displayed as double circle in the transition diagram. Now, here we see some of the example for defining the deterministic finite automata. So the first example is nothing but here, design a DFA of alphabet A comma B. So the input alphabet which we are taking here, that is nothing but small a comma b, which accept the string AB. That means here, whenever you design a DFA, in the DFA, your input, like the substring, it should be compulsory, it should be the AB. So for that first step, here we are going to understand the DFA. We are designing the DFA and writing the language for that. So first, how to write the language? As it is given in the question that whenever you write a language or whenever you design a DFA, in the DFA, the substring, it should be the AB. So the language can be AB, it can be AAB, it can be AAB, so on. So whenever, for example, like this, AB, BAB, AB, BA, so on. So you can see here the substring is AB, 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 so on. So the length of the string, minimum it should be how much? Minimum it should be 2. So maximum it can be the anything. That is the first thing. Second step, draw the transition diagram for the minimum length of the string. Now if you can see here in the language, whatever we have written, so the language, the minimum length of the string is 2. So when we have minimum length of the string is equal to 2, when we design a DFA, the transition states should be n plus 1. That means, for example, if we have, here we can see the length is equal to 2 or n is equal to 2. So whenever we design a transition diagram, that can be 2 plus 1, that is equal to 3. Okay. So here we will draw the transition diagram and just check it out here. So as we said that n plus 1 whenever we are defining a DFA depending on the condition. So here we take a 3 states, Q0, Q1, Q2. And as we discussed in the DFA that each and every state should have exactly one transition from inputs. That means if suppose we are having the 2 inputs, so each and every state should have exactly one transition from that both input. So what is the language given here? AB. That means exactly AB should be there. That means whatever the string you write, in that string, AB should be there. That is the condition which is given in the question. Second thing, what is that? Your diagram should be satisfy the DFA condition also. That means if you can see here, we have 3 states. Now from each and every state, from Q0 we have A transition, from Q1 we have B transition. But what about here Q2, Q0 we don't have any transition, because as A is completed, we can give a other transition which is known as B. Now from Q0 A is completed, from Q0 B is also completed. In the same way, from Q1 we have B. What is the other input transition which we can give? That is A. Now from Q2 we don't have any transition. So here we can give A comma B. This is your transition diagram for the above question given. That means if you can see each and every state, 3 states having the transition with A as well as B, as well as it is satisfying the question or the condition which is given in the question. Okay, so here it is given, as we have already taken 3 states, Q0, Q1, Q2, and the input alphabet is A, B. What is the initial state here? We have taken in the previous diagram, which you can see Q0, and what is the final state? That is Q2. So for example, here we take one string and have just verified whether it is satisfied or not. Simply you can just check it out. Q1 of A. Q1 of A, that means if you see in the transition diagram, what is Q1 of A? Q1 of A is nothing. Q0 of A. Q0 of A is nothing but Q1. In the same way, Q1 of B. What is Q1 of B? Q2. That is Q2. Next, Q2 of B. Q2 of B is nothing but Q2 itself. Q2 of A is also Q2 itself. That means it is accepted. When the state is accepted in a Q2, that we can say that it is accepted. In the final state, whenever it ends, we can say that it is accepted. Now we'll see with one more example here. Construct a DFA which can accept a string over the input alphabet A, B, a string starting with A. So here, string starting with A. So for that, first we write the language. That means what? A string can start with A, okay, can end with A, B. That means starting it should be every time A. It should not start with the B. That means your string should start with every time with A, not with B. And ending is there is no condition given, so simply we can give that it can end with A or end can B. So we can write here A, we can write AB, ABB, ABA, so on, anything. The language can be anything, but whenever you write a string in the language, it should always start with A. Now you just see what is the minimum length of the string in the language it is given. That is n is equal to 1, right? So what it can be in a DFA? It should be n plus 1. That means whenever we draw a transition diagram, the state should be 2 states. Okay. Now let's go with the diagram here. Already the diagram is given. So we take a 2 states here, Q0, Q1, and Q1 is the final state. So here it is A, right? So it can start with A. If I give self loop and write B, that means this is wrong. Why? Because it has the condition that means if I give a B self loop, that means it can have the possibility to start with B also. So we should not give B here. And as we said that it can end with A, B. So this is generally the condition, the diagram, whatever the condition which is given in the question. But this is not a DFA. Why it is not a DFA? Because Q0 have a transition with A, but not with B. So in that case, even we can't give like this also. If you give like this, again it has the it have the possibility to start with B also. So what we can do here we can take one state that is known as the dead state, or we can say trap state, okay, and we can give what as a B input transition. This is a dead state. It does not have any work. Just to complete the DFA, we are giving a dead state. As well as for this state, we can give a transition A, B, because as we said that DFA should have each and every input transition. So already it is given here, the same diagram. Now, coming to the tuple representation, how many states we are having? Q0, Q1, right? What is the input alphabet A, B? What is the transition function? Transition function is nothing but like this. We have to denote the transition function. Transition of Q0 of A, transition of Q0 of B, transition of Q1 of A, transition of Q2 of B, Q0 of A, Q1, Q0 of B, that is nothing but dead state, QD, Q1 of A, same Q1, and Q1 of B, same Q1. This is known as a transition function, right? And also we have given with the initial state as well as the final state. The next example here we are going to see, construct the DFA for accepting string over the alphabet A, B ending with B. Previously we checked, we have designed a DFA which start with A. Here we are saying end with B. Now, what can we write? the language for this, ending with B. That means what? The DFA can start with A, right? The DFA can start with B, so on, but ending every time it should be B only. Ending every time it should be B only. That means the DFA can start with A, start with B, but ending every time it should be B only. So for that we design a DFA for that. So here the minimum length language which we can take, that is B. Okay, it can be B, it can be AB, it can be AAB, it can be AB, so on. But minimum, what is that? It is a single B. That means if n is equal to 1, DFA can be written as n plus 1, that is 2 states. So we have taken with the 2 states Q0, Q1. Now, if it is only 1B, simply Q0 is moved to Q1 with the final state, right? Q0 to move to Q1, that is final state. Now we have to check with an each and every condition whether we are getting each and every state with the input transition or not. So Q0 of B already gone. That means, example here, Q0, Q1. So the first condition B. Now coming with this input, with this state, already B transition is there. Can we give an input as an A transition? Yes, because your input, that means your DFA can also start with A. Here, last it should end with the B. That means we can we give B? Yes. Q1 with B completed. What about Q1 of A? No need of moving in a dead state, because if you have the possibility, if you can move to the previous state, you can just move it. Yes, we have the possibility. So we are moving to the previous state. So this is the transition diagram for the given question. In the same way, the transition function will be Q0 of A, Q0 of B, Q1 of A, and Q1 of B. So Q0 of A is nothing but Q0, Q0 of B is nothing but Q1, Q0 of A is nothing but Q0, and Q1 of B is Q1 itself. This is the transition diagram. So this is the thing which we are going to explain in the DFA, that is the deterministic finite automata. Hope you understand the concept, whatever it is explained here. So in the next topic, we are going to discuss about the non-deterministic finite automata. We'll discuss about the non-deterministic finite automata, and also we discuss about the 5 tuples which there in the non-deterministic finite automata, as well as with the example. Thank you.